Imagine a world devoid of instant communication, a time when the fastest means of sending a message was limited by the speed of a horse or a ship. Before the mid 19th century, conveying information across continents could take weeks, even months. The constraints of distance hindered commerce, diplomacy, and personal relationships. No telephones, no internet, no satellites, just the relentless wait for news from afar. But in 1837, an invention emerged that would revolutionize this paradigm: the electromagnetic telegraph. At the forefront of this breakthrough was Samuel Finley Breese Morse, an American polymath whose relentless pursuit of innovation transformed global communication. Today, we delve deep into the life and work of Samuel Morse, exploring his technical challenges, the intricate development of the telegraph, and the enduring impact of his contributions on modern communication networks. Samuel Morse was born on April 27, 1791, in Charlestown, Massachusetts. As the eldest son of Jedediah Morse, a distinguished geographer and clergyman known as the father of American geography, and Elizabeth Ann Finley Breese, Samuel grew up in an environment steeped in academic rigor and religious piety. At the tender age of 4, he attended a local dame school where an elderly infirm teacher wielded a long rattan stick to maintain discipline. Despite the austere setting, young Samuel exhibited a precocious talent for art, often sketching caricatures of his teacher and classmates instead of focusing on his lessons. These early expressions of creativity hinted at the dual passions that would define his life: art and science. In 1805, at age 14, Morse entered Phillips Academy in Andover, Massachusetts, one of the premier preparatory schools of the time. His academic excellence led to his admission to Yale College, now Yale University, in 1807. Yale provided Morse with exposure to cutting-edge scientific inquiry, particularly in the field of electricity, then a subject of fascination and rapid development. Under the tutelage of Professor Jeremiah Day and Benjamin Silliman, Morse attended lectures on electricity and chemical phenomena, witnessing experiments with voltaic piles and electromagnetic induction. However, financial hardship compelled him to seek ways to support himself. Leveraging his artistic skills, he painted miniature portraits on ivory, an intricate and sought-after art form, especially in an era preceding photography. His diminutive artworks, often measuring less than 2 inches in height, provided essential income while he pursued his studies. After graduating from Yale in 1810, Morse aspired to combine his artistic talent with his intellectual pursuits. In 1811, he traveled to England to study painting under the renowned artist Washington Allston. Immersed in the Romantic movement, Morse developed a profound appreciation for historical and mythological subjects. His notable works from this period include Dying Hercules, a dramatic representation that reflected neoclassical influences and showcased his mastery of anatomy and composition. Despite his artistic growth, the War of 1812 between Britain and the United States strained his resources, forcing him to return home in 1815. Back in America, Morse faced limited demand for grand historical paintings. The nascent nation favored portraits and practical artwork, prompting him to adapt. He became one of the era's eminent portrait painters, capturing figures such as President James Monroe and Eli Whitney. Yet financial stability remained elusive. Parallel to his artistic endeavors, Morse harbored a keen interest in invention and mechanical devices. His intellectual curiosity led him to explore various technological challenges. In 1817, he conceptualized a flexible piston reciprocating pump designed to improve the fire engine's efficiency. Though the invention was patented, it failed to achieve commercial success due to mechanical limitations and the lack of robust manufacturing infrastructure. Undeterred, Morse continued to experiment. In 1823, he patented a marble cutting machine capable of carving 3-dimensional sculptures, demonstrating his ability to intersect art with engineering. These early inventions, while not financially fruitful, honed his problem-solving skills and deepened his understanding of mechanical systems, expertise that would prove invaluable in his future work. The seminal moment in Morse's career occurred in 1832 during his return voyage from Europe aboard the packet ship Sully. Engaging in discussions with fellow passengers, including Dr. Charles T. Jackson of Boston, Morse was introduced to the recent discoveries in electromagnetism by European scientists like André-Marie Ampère and Georg Ohm. The conversation turned to the possibility of instantaneously transmitting messages over long distances using electricity. Morse was captivated. If electricity's speed was virtually instantaneous, could it not be harnessed to communicate across vast expanses? He pondered. If the presence of electricity can be made visible in any part of the circuit, I see no reason why intelligence may not be transmitted by electricity. During the remainder of the voyage, Morse sketched designs for an electromagnetic recording telegraph. These drawings included the conceptual framework for a single-wire system, a significant departure from earlier, more complex multi-wire approaches. The concept of an electromagnetic relay also emerged, envisioning a system that could boost signal strength over extended distances. Back in the United States, Morse faced the formidable challenge of transforming his theoretical designs into a working prototype. At the time, existing electrical knowledge was rudimentary, and components like insulated wires and reliable power sources were scarce. Morse constructed a rudimentary apparatus using materials at hand, including a canvas stretcher frame, a homemade battery, and parts from a clock mechanism. His initial experiments demonstrated the feasibility of using electromagnetic pulses to produce mechanical movement, a foundational principle for a recording telegraph. The lack of resources and technical assistance hindered progress. However, in 1835, Morse was appointed professor of painting and sculpture at the University of the City of New York, providing him with a platform to continue his experiments. At the university, Morse collaborated with Leonard Gale, a professor of chemistry with a deep understanding of electromagnetism. Gale introduced Morse to Joseph Henry's work on electromagnets, particularly the concept of the intensity magnet, which allowed for stronger magnetic fields with reduced current over long distances. In 1837, a serendipitous encounter with Alfred Vail, a recent graduate of the University of the City of New York and skilled machinist, proved pivotal. Vail possessed both the technical expertise and the financial backing of his father, Judge Stephen Vail, proprietor of the Speedwell Iron Works in New Jersey. Vail's contributions were substantial. He engineered precision components, improved the receiver's mechanical design, and critically, he refined Morse's signaling method. Instead of the cumbersome and error-prone system of numerical codes corresponding to words in a dictionary, Vail developed an alphabetic code using dots and dashes, what would become the Morse code. This binary-like system capitalized on the simplicity and efficiency of representing letters through variable signal lengths. On January 6, 1838, Morse and Vail publicly demonstrated their electromagnetic telegraph at the Speedwell Iron Works. Using a 2-mile length of wire, they successfully transmitted messages between different parts of the facility. The message, "A patient waiter is no loser," was sent and accurately received, impressing the attendees. Despite this success, skepticism remained widespread. Many contemporaries questioned the practicality of the telegraph, doubting its ability to transmit over the vast distances required for meaningful communication. To persuade potential backers, Morse showcased the telegraph in various cities, including an exhibition to President Martin Van Buren and his cabinet. However, securing substantial funding proved elusive. Realizing that private investment was insufficient, Morse turned to the federal government. In 1838, he petitioned Congress for appropriations to build an experimental telegraph line. After several years of persistence, during which he continued refining his apparatus, Congress approved an appropriation of $30,000 on March 3, 1843. This funding aimed to construct a telegraph line between Washington, D.C. and Baltimore, a distance of approximately 40 miles. Securing this appropriation was a significant achievement, yet it came with challenges. The political climate was fraught with competing interests, and Morse faced opposition from those who considered the telegraph a speculative venture unlikely to yield practical benefits. Morse initially planned to lay the telegraph wires underground, employing a trench with lead pipes to protect the cables. This method was influenced by European practices and aimed to safeguard the wires from environmental damage and tampering. However, the lack of effective insulation materials led to repeated failures. The insulation, comprising cotton wrapped in tar, proved inadequate, resulting in signal loss due to electrical leakage into the ground. With funds dwindling and pressure mounting, Morse made a strategic decision based on advice from his associates, including Ezra Cornell, who proposed the use of overhead lines suspended on poles. This approach reduced costs and facilitated maintenance. By early 1844, construction progressed rapidly, with poles erected along the route and wires strung using glass insulators to prevent electrical leakage, a novel solution at the time. On May 24, 1844, the system was ready for its inaugural test. In the chamber of the U.S. Supreme Court, located in the Capitol building, Morse prepared to send the first official message to Alfred Vail at the Mount Clair Depot in Baltimore. The message selected was, "What hath God wrought?" a phrase from Numbers 23:23 in the Bible. This selection was suggested by Annie G. Ellsworth, the young daughter of Henry Leavitt Ellsworth, the commissioner of the U.S. Patent Office and an early supporter of Morse's work. The message underscored the momentous nature of the occasion. As Morse tapped the key, the electrical impulses traveled along the wire at the speed of light, instantly reaching Baltimore, where Vail received and confirmed the message. The successful transmission validated years of effort, heralding a new era in communication. Despite this milestone, widespread adoption of the telegraph was not immediate. Many in the public and business sectors remained skeptical, perceiving the technology as a novelty rather than a utility. The initial telegraph line operated sporadically, and operators often faced technical difficulties. However, key events demonstrated the telegraph's potential. In 1845, the telegraph was used to relay news of the nomination of James K. Polk as the Democratic candidate for president from Baltimore to Washington, outpacing traditional couriers. The rapid dissemination of news showcased the competitive advantage afforded by the telegraph. Entrepreneurs recognized the commercial opportunities. By 1846, the Associated Press was formed, utilizing the telegraph to share news among multiple newspapers. Lines extended to New York and Philadelphia, although technical limitations with underwater cables necessitated alternative solutions. Messages were telegraphed to the nearest point and then conveyed by ferry or courier across rivers. Samuel Morse's achievements eventually garnered international acclaim. He secured patents in numerous countries, though he faced legal challenges, notably in the United Kingdom, where Cook and Wheatstone's earlier telegraph system contested his claims. Nonetheless, his contributions were widely acknowledged. In 1858, representatives from 10 European countries awarded Morse a sum of 400,000 French francs, recognizing his role in developing telegraphy. He received honors such as the Order of the Tower and Sword from Portugal and was elected to prestigious scientific societies. Financially secure, Morse invested in real estate and supported philanthropic causes, including educational institutions and charitable organizations. He continued to engage with technological advancements, particularly the efforts to establish transoceanic communication. The success of the telegraph spurred rapid expansion. Competing companies emerged, leading to fragmented networks and conflicting technologies. In response, the Western Union Telegraph Company was formed in 1856 through the consolidation of several major telegraph firms. Western Union standardized equipment and codes, facilitating a cohesive national network. Technological innovations continued unabated. In 1858, after several failed attempts, Cyrus W. Field succeeded in laying the first transatlantic telegraph cable, connecting Europe and North America. Although the initial cable functioned for only a few weeks, it proved the feasibility of transoceanic communication. By 1866, a durable cable was established, integrating global communication networks. Advancements such as duplex and quadruplex telegraphy, enabled by inventors like Thomas Edison, allowed multiple messages to be sent simultaneously over a single wire, increasing efficiency and capacity. The legacy of Samuel Morse and the telegraph is profound. The fundamental principles of electrical signal transmission underpin our modern telecommunications infrastructure. Fiber optic cables, satellites, and wireless networks all trace conceptual lineages back to the early telegraph systems. While Morse code is no longer essential for mainstream communication, it remains relevant in niche applications. Amateur radio operators, military signaling, and aeronautical navigational aids continue to utilize Morse code for its simplicity and reliability under adverse conditions. The telegraph also set precedents in regulatory and legal frameworks for communication technologies, influencing policies on intellectual property, standardization, and international cooperation. Samuel Morse passed away on April 2, 1872, in New York City, leaving behind a transformative legacy. His life embodies the intersection of art and science, illustrating how interdisciplinary approaches can yield groundbreaking innovations. Morse's perseverance in the face of financial hardship, technical obstacles, and skepticism serves as an enduring inspiration. His work not only revolutionized communication, but also laid the groundwork for the interconnected world we inhabit today. As we reflect on the evolution from the electric telegraph to instantaneous global communication, we acknowledge the foundational contributions of pioneers like Morse. Their vision and tenacity remind us that innovation thrives at the nexus of creativity, knowledge, and unwavering determination.